Welcome back to the morning show. It's Wednesday Wise Guy time, and our Wise Guy is back from a little hiatus. Matt Sellon, U of I physics professor, is here, and Happy New Year, Matt.
Well, Happy New Year to you, too.
And speaking of the new year, we're talking about the calendar, the planets, alignment, and how things work as such.
Right. So I was thinking what to do in the new year, and we couldn't talk about driving in the ice and snow because, well, there's no ice and snow. And I thought, well, the calendar is kind of interesting. And then I didn't know how interesting it was until I went on the internet, of course, and read about it and looked in some books and things. And the history of the calendar is fascinating. And I will put a bunch of links on my website so other people can see this too. But it's really cool.
Okay.
And so I'll just give you, I'm not a historian, and so I don't remember dates well and things like that.
I don't either.
But I'll give you kind of an idea of what I learned by reading up on this stuff over the last week or so. So astronomy, well, people have always wondered about how things work, right? And so people noticed long time ago, thousands of years ago, the Egyptians, of course, everybody sees the sun goes across the sky, the moon sometimes goes across the sky, the stars move around. And so people are curious to try to predict how this all works. When does it repeat and why does it happen and things like that. And so people would look up at the sky and they would see that, okay, the Earth spins around, and then they could also keep track of the moon. That was pretty simple. And then there were seasons. There was summer, winter, and so on. And people could even keep track of years pretty accurately because they could look for these things called equinoxes, and I'm going to explain what that is in here in just a second.
Okay.
The physics of all this, by the way, just so we know a little more than they knew at the time, is that the Earth spins on its axis.
Right.
And when something spins on its axis, like this gyroscope, which is not supposed to hypnotize you, it's just supposed to spin on its axis, right? When it moves around, it always still points in the same direction. The spinning part does. Okay, so if I pick this thing up and I move it around like this, it doesn't really matter how I move this thing. It still points
pointing right out there.
Always that way. Okay, so the Earth is kind of the same way. Suppose the Earth is this apple. Shove a pencil through it, okay? So now the pencil is the rotation axis of the Earth. The Earth goes around the sun. Okay, so you're going to be the sun. The Earth goes around like this, and it goes behind your head and it comes around like this. That motion takes exactly 1 year.
Right.
Okay? The Earth also spins on its own little axis like this. Every time that spins around once, that's a day. Now, if the Earth pointed straight up and down, if this axis, this pencil, was perpendicular to the plane in which it rotated around the sun, then you would not be able to tell one day from the next because things would always look the same. But the Earth actually is tilted over by about 24 degrees. And so sometimes of the year, you have the sunshine kind of on the bottom part of the Earth. And then later on, 6 months later, when it's over here, you can look at this way now. Here you go. You're still the sun, by the way.
I got you.
Now the sun is shining on the top part of the Earth. Okay. So since we live here on the top, at around 40 degrees on the apple, about where that dot is right there. Okay. In the summer, when we're kind of tilted towards the sun's rays are hitting us, and it's nice and warm. In the winter, when we're around on this side, the sun's rays are hitting down here more, and they're kind of glancing off us. We're not getting as much of it, so it's cold.
Very good.
And so that's what makes the seasons. And what people observe and what people have been trying to predict, or can actually observe very well throughout the years, are things called equinoxes, which means that, okay, so I said this is a summer or winter for us, summer is on the other side. Halfway around, let me go like this, when now the sun is, the spinning axis is pointing either towards the camera or on the other side, still towards the camera, but we're kind of halfway on. Okay. During those 2 days of the year, over there and over there, people on the Earth observe that the sun rises exactly in the east, or exactly, well, it's always exactly in the east, and it always sets exactly in the west. But in those times of the year, it comes up exactly where you think east is or where west is. Okay? And so you could pick that day very accurately. Those were called equinoxes, and they had very special significance for people.
Oops.
Okay? And so it was the time between equinoxes which people called a year. And the Egyptians knew even 4,000 years ago that the time between equinoxes was 365 and a quarter days, because they kept very careful track of these things. The problem was, people, even though they knew that, they also knew that the moon went around the Earth, and they kind of kept track of that, and that was, 28 and something days, and then there was a little more than 12. The moon went around the Earth a little more than 12 times in a year. Nothing was an integer. Nothing happened exactly the 2, 3, 28, 12 times in a year. And so that's what confused people. Well, it made people not really agree on how to keep track of these things, because some cultures figured the sun was more important, some figured the moon.
Very good. Okay. We could go on all day, but
we could.
We're getting the wrap sign.
Oh,
so
my gosh.
We'll come back in 30 minutes and further explain all this.
Yeah, I have some more stuff, and I won't talk quite so much.
No, it's okay. We love it when you do that. All right, if you have questions for Matt, there's the